Hello students, today we are going to be going over 15.2, Standard Deviation. Our objective is I can calculate and interpret standard deviation. There's a lot of vocabulary that goes on in here and I will try to explain it as best I can, but some of these I think you're just not going to get until we actually start going through the whole unit. So first we'll start with measures of central tendency. This is a summary statistic that represents the center point or typical value of a data set. These measures indicate where most values in the distribution fall and are also referred to as the central location or distribution. You need to cross out this W so that this says R. Examples of a measure of central tendency are mean, median, and mode. And just to review, mean is like the average of all the numbers. Median is the middle number when you line them up from lowest to highest. And mode is the most number listed. Okay. Next, we're going to talk about measures of distribution or variability. They are statistical measurements that describe the amount of difference in spread in a data set. And some examples are all of these different things, and we'll talk about some of those things later. Standard deviation is a measure of how spread out numbers in a data set are. Like, are they going to be close together or are they really spread apart? Standard deviation is a measure of variability or distribution. Population data. The data set contains all members of a specific group. The entire list of possible data values. On the TI-84 Plus calculator, this little symbol here, X, represents standard deviation for population data. Sample data is the data set contains a part or a subset of a population. The size of a sample is always less than the size of the population from which it is taken. On the TI-84 Plus calculator, the big S with the X represents standard deviation for sample data. Interquartile range, IQR, is the range of the box in a box and whisker plot. It is calculated by subtracting Q1 from Q3, and you'll get IQR from the Q3 minus the Q1. We'll go over that later. Okay, some of these I'm not going to go over all of them. N is the number of values in a data set. X bar is the mean or the average. Capital S with the little x, that's the standard deviation for sample data. This little symbol here with an X is the standard deviation for population data. This is a summation sign X. It's the sum of all the numbers. This is the sum of all the numbers squared. So, and then over here, statistical values calculated by TI-84 Plus calculator. Basically, it's some of the same things I've already gone through. So I'm not going to go through them again. We're just going to go on to the next page. Joe has these test scores. Sam has these test scores. And to be population data, what do we need to make sure? Population data is going to make sure that it must include every test taken. To be sample data, it is a sample of the tests taken, comma, but not all of them. Okay, so calculate the mean test scores. So here's the means of Joe's test data. We go back up here. We added every single one of these all together, and we would divide it by how many tests he took. 1, 2, 3, 4, 5, 6, 7. So that's why we divide it by 7. And again, this is the symbol for mean, or you could also call it X bar, or average is 80%. Okay. The mean of Sammy's data scores, we are going to say, we're going to add them all together, 78 plus 78 plus 79 plus 79 plus, let's see, we have 279, we have 382s. And we're going to take all of that and we are going to divide by 7. So we have 278s, 279s, 382s divided by 7. Okay? Now, we're going to say mean, or you can draw the x bar for x, and I don't know how to do the x bar on this, equals, we add them all together, divide by 7, and we get 80. What can you infer from the mean scores? I would say not much because they're exactly the same, right? They are the same. The mean did not tell much about the characteristics of the test takers. Using another measurement will reveal more information. Standard deviation will show the spread in the data sets. Okay? Again, step 1. Standard deviation is a measure of spread about the mean of the data. Write down the mean, specifically x bar, of the data calculated above. They're both 80. We know that. Okay? Deviation is the distance from the mean for each piece of data. Find the deviation by subtracting the mean from each data point. Given x bar is the mean of the data set. Then the deviations of the data from the mean would be found by computing x1 minus x. So we have 60 for Joe's first test score, minus 80 is this, 68 minus 80 is that. So we're going to find the deviation for Sammy's scores. The first one he had is 78, and we're going to subtract it from 80, and we get -2. Okay, the next one he got a 78 minus 80 equals -2. The next one is 79 minus 80 equals -1. And then we got 79 again, minus 80 equals -1. Then we get 82 minus 80 equals 2. 82 minus 80 equals 2. 82 minus 80 equals 2. Okay, so look at the deviation between the two scores. Okay. All right, so what can you infer from the deviation? We can say that for Joe, he's got a wide variety of his scores, whereas Sammy, pretty much the same. So what can you infer? Maybe Joe got some extra help when he started doing much better on his tests, his last 3 tests, and maybe Sammy's just on his own. Okay, let's go on to the next one. Variance, symbolically s squared, is the mean squared deviation. It is calculated by squaring each deviation and finding the mean of these squares. So the variance for Joe's scores are this. So we square each one and add them all together and divide by 7. So if we do the same for Sammy's scores, we know that Sammy has -2 squared. Okay, so that equals 4. And then, again, -2 squared is 4. And then the next one is -1. It's squared is 1. And then we have another negative 1. And that's 1. And then we have another 2 squared. It's 4. And we have another 2 squared. 4. And the last one is 2 squared is 4. So if we take, again, the variance of the squared, it's the mean squared, so we can add all of them together here. We can go, how many 4s are there? 4 times 1, 2, 3, 4, 5. 5. Plus, there's 1, 2 ones, plus 2. We're going to take that whole thing and divide it by how many numbers there are. Take that and divide it by 7. If we do that, we get 22 over 7, which is 3.143. Okay. So, step 5, the standard deviation, or this symbol, is the square root of the variance. Symbolically, this is the square root of that. Okay. So, standard deviation. For Joe's data, again, it was the square root of s squared is 14.11. For Sammy's scores, we're going to say it is, again, that weird symbol, I'm going to just put a little a equals square root. Oh, where's the square root function? Oh. Of 3.143, and that equals 1.77. So the mean for Joe's data, okay, so here we have 80. And remember the mean for Sammy's data was also 80. If you look at the median, oh, maybe I should start a new one here. The median for Joe's data is 78. Again, the median is going to be, if you list the numbers from least to greatest, it'll be the middle number. And for Sammy's data, it was 79. So that's not telling us too much difference there. Okay. The range is 40 for Joe's data. And for Sammy's data, it's 4. So there's a big variation in Joe's data. Okay, so the variance was 199. Let's go here. Actually, they wanted 199.143. Sammy's data is 3.143. Standard deviation is 14.11 for Joe's data and 1.77 for Sammy's data. Why do you think the standard deviation of Joe's test score is higher than the standard deviation of Sammy's test scores? Well, Joe's data has a wider spread. Sammy is more consistent. What does standard deviation tell you about the data set? In other words, what does the standard deviation measure? It measures spread, consistency, how far from the mean the values are located. The closer to the mean, the smaller the standard deviation. Okay. All right. Hopefully that'll help you figure out how to do the rest. Good luck, students. You rock.